So let's discuss one very good example, as to how the, electrostatic EMF, get together in a particular situation. So let's see, this is a example of a rod. So that's your rod. It's a metallic rod, and this metallic rod is being made to move downwards with velocity v, and what you have is a magnetic field which is outward. So I'm going to show the magnetic field which is with the help of dots. Okay, so these are the dots of these represent the magnetic field. Okay, so these are your outward lines of forces, and that's your magnetic field. Okay, and just these are, assume them to be uniform, equally spaced. So you have this magnetic field, all over, and it's outward. It is coming out of the plane of the board, and so never worry about this. It is actually a straight, situation. And okay, now remember that all these, this rod is a metallic rod, and therefore this rod has electrons in it. Okay, so this rod has electrons, and it is full of electrons. Okay, now I'm showing you the electrons, and these electrons, when they are moving downwards in a magnetic field, because the rod is moving downwards, what happens is the electrons experience a force. And I told you about right-hand rule. So you can see that the magnetic field is outward, the velocity is, in downward direction. Okay, the magnetic field is outward. I'm showing the velocity upward. It is downward actually, and because the charge is negative, so I can invert the velocity. Instead of downward, I can show it up. That will take care of the right-hand rule to be applied only for positive charges. Since the velocity is downward, I have made it upward because I'm dealing with electrons. My force is towards the left. So all these electrons experience a force on the right-hand direction, which is given by BeV, right, from the formula BQV. So what happens in the final state is that all these electrons, which are moving in a magnetic field, because they're inside a rod, they experience this force and they start moving towards the right and start getting accumulated, on the right-hand side. So there is a tremendous, collection of electrons. So this side of the rod, this particular side of the rod gets a lot of electrons, and therefore this side of the rod becomes electron deficient. So the electrons are moving towards the right because of the force BeV. This side is becoming more and more negative, and this side is becoming more and more positive. Okay, and this is becoming more and more negative. So at some point what happens is, even though you have the force which is acting down towards the right hand side, what you do end up is setting up an electric field which is in this particular direction. So this is your electric field that gets set up inside the rod, and the electrons are, now you can see the electrons will not move towards this, they will stop. So at that point of time, the electric field force, which is EE, cancels BeV, the magnetic force due to motion, and EE will get cancelled, and therefore E by B is equal to velocity. At this stage, this side of the world has become negative and this side is positive. And now what you have is setting up of an electric field inside the rod. One side is positive and one side is negative. And therefore what you have is EMF, which is the electromotive force, across the two ends of the rod, right? So if you connect this rod to an external circuit, the current will flow. But this is an example of what is called as, the motional, EMF, where a metallic rod moves inside a magnetic field which is perpendicular to the direction of velocity. The electrons start moving on some side. They collect, they become negative, and wherever they don't exist, because of the deficiency, it becomes positive. What you have is creation of a potential difference called as EMF available, right? So the motion or the interaction of the charge with the magnetic field, the charge being in relative motion with the magnetic field, resulted in generation of an EMF. And this concept is called as motional EMF. Very, very important if you're preparing for JEE Mains, NEET, Advanced Placement, Cambridge, IB Board, or wherever you study. It's all across same. Physics does not change. All right, so I hope this helps you. And you like my video. If you do, you can go and see my YouTube channel. I have more than 1,500 videos on my YouTube channel. You can go through them and enjoy the videos. I didn't have much equipment, so some of the production quality is bad, but if you listen to them, they're short videos, they will make a lot of sense to you if you're a physics student. Thank you.